Before we dive in, please remember that this presentation is for educational and informational purposes only. The requirements for engineering licensure can vary significantly by state and are subject to change. I am not an employee or representative of any state licensing board or NCEES. You must always consult the official website of your specific state's engineering board for the most current and accurate requirements. This video is intended to be a comprehensive guide, but it is not a substitute for official counsel. Did you know that a professional engineer earns, on average, over $20,000 more per year than an unlicensed engineer with the same experience? Let that sink in. $20,000 every single year. Over a 40-year career, that's not a rounding error. That's $800,000. That is a life-changing amount of money. It's the difference between hoping you can retire and knowing you can. But for so many brilliant, hardworking engineers, that massive pay bump, that prestige, that career security feels like it's locked behind a steel door. And the key is hidden in a maze of confusing state board websites, conflicting advice from senior engineers, and a fog of acronyms like NCEES, GIT, and ABET. It feels like a secret club and no one ever gave you the password. You've hit a ceiling. You see the project managers, the principals, the ones signing and sealing the plans, the ones with the final authority, and they all have those two little letters after their name P. Well, consider this your official invitation to the club. In this series, I'm not just giving you the password, I'm handing you the master key. This is the definitive step-by-step roadmap to becoming a licensed professional engineer in the United States. We are going to demystify the entire process, from your first day of college to the moment you hold that license in your hand. We will cut through the noise, eliminate the confusion, and replace anxiety with a clear, actionable plan. By the end of this series, you won't just understand the path. You will have a personalized strategy to conquer it. Because this is about so much more than money. Becoming a PE is about transforming your career from a job into a profession. It's the difference between executing someone else's vision and having the authority to create your own. It's the legal and ethical stamp that says, I am competent, I am responsible, I am entrusted with the health, safety, and welfare of the public. When a bridge stands firm in a storm, when a building's electrical system works flawlessly, when clean water comes out of the tap, it's because a professional engineer put their name, their reputation, and their entire career on the line to say, this is safe, this will work. That is the true power of this license. It's the ultimate mark of credibility. It unlocks the ability to start your own consulting firm, to testify as an expert witness, to manage multi-million-dollar public works projects, and to reach the highest echelons of technical and corporate leadership. Without it, you will always be working under someone else's authority. With it, you become the authority. So how do we get there? I've seen countless people get overwhelmed because they try to understand everything at once. But the entire journey, no matter your discipline, civil, mechanical, electrical, or otherwise, boils down to 4 fundamental pillars. For major milestones you must achieve in a specific order. Think of it like a video game with 4 main levels. You can't skip to the final boss. You have to conquer each level to advance. Those 4 pillars are 1. Education, 2. The fundamentals of engineering exam, 3. Experience, and 4. The principles and practice of engineering exam. That's it. Education FE exam, experience P exam. Every single requirement, every form, every fee falls under one of those 4 pillars. And today we're starting with the foundation of it all, education. This might sound obvious, but it's the most critical and often misunderstood first step. To even begin the journey to licensure in nearly every state, you need a degree from an EAC/ABET-accredited engineering program. Let's break that down. ABET stands for the Accreditation Board for Engineering and Technology. It's the gold standard, the nonprofit organization that validates engineering programs in the United States. They ensure that a curriculum at a university in California meets the same rigorous standards as one in New York. When a state licensing board sees an ABET-accredited degree on your application, it's an instant checkmark. They know you've been taught the necessary math, sciences, and engineering principles to a recognized national standard. This is non-negotiable. If you are in high school or college right now, your #1 priority is to ensure the program you are in or plan to attend is ABET-accredited for your specific engineering discipline. You can go to the ABET website right now and search for your school. Don't assume. Verify. Choosing a non-accredited program is the single biggest and most difficult mistake you can make at the start of your career. Now, what if you're listening to this and you have a sinking feeling because your degree is not from an ABET-accredited program? Maybe you have an engineering technology degree, a degree from a foreign university, or a related science degree like physics or chemistry. First, don't panic. It does not mean your dream is over, but it does mean your path just got more complicated. You will have to go through a process of having your education evaluated, typically by a service like NCEES credentials evaluations, to see if it's deemed substantially equivalent to an ABET-accredited degree. This often means taking extra college courses to fill in any gaps the board finds in your education. It can add years and thousands of dollars to the process. It is a much steeper hill to climb, which is why I stress the importance of ABET accreditation from the very beginning. For the rest of this series, we're going to proceed with the assumption that you have or are pursuing that gold standard ABET degree, as it represents the most direct and common path. But your education isn't just about passing classes and getting a piece of paper. The mindset you adopt during your 4 years of university is what separates the students who coast into their EIT certification from those who struggle after graduation. Your PE journey does not start when you get your first job. It starts in your freshman-level calculus class. Every course is a building block for the massive exams that lie in your future. Don't just learn to pass the test. Learn for retention. The thermodynamics or circuit analysis you learn as a sophomore is exactly what you'll see again on the FE exam years later. Start thinking of yourself not as a student, but as an engineer in training from day one. Furthermore, your education pillar includes internships and co-ops. This is your first taste of real-world engineering. More importantly, it's where you begin to build your professional network. The supervisor you have at your summer internship could be the PE who writes you a letter of recommendation for your license application 5 years down the road. Treat every single day of your internship like a long-term job interview, because it is. Show up early, ask intelligent questions, and demonstrate a hunger to learn. This is where you start building the reputation that will define your career. So, the first pillar is a degree from an ABET-accredited program, supplemented with a professional mindset and real-world experience through internships. This degree is your entry ticket. Proves you have the foundational knowledge. But having a ticket doesn't mean you're in the game. To get on the field, you have to pass the first major gatekeeper, the test that separates the students from the certified professionals in training. It's a 5-hour and 20-minute, 110-question marathon of an exam that will test every single thing you learned during your undergraduate degree. It's called the Fundamentals of Engineering exam, or the FE. And passing it is your next critical mission. This exam isn't just a test of what you know. It's a test of how you think, how you manage pressure, and most importantly, how quickly you can find information. Imagine a library containing the core principles of a dozen different engineering subjects. Now imagine that library is on fire, and you have about 3 minutes to find the right book, the right chapter, and the right sentence to solve a problem before moving to the next one. That's the FE exam. The National Council of Examiners for Engineering and Surveying, or NCEES, the organization that runs this whole show, knows you can't possibly memorize every single formula. They're not sadists. They're engineers. They're practical. So they give you a tool, a lifeline. It's a searchable PDF document, hundreds of pages long, called the NCEES FE Reference Handbook. And this handbook is the single most important key to passing the exam. Your mission, should you choose to accept it, is not to memorize thousands of equations. It's to become an absolute master of this one digital book. You need to know its structure, its quirks, its layout, better than you know your own phone. You need to be a digital librarian, a search and rescue expert for formulas. The exam itself is a 5-hour and 20-minute marathon, split into 2 sections with a short break in between. It's all multiple choice, taken on a computer at a designated testing center. 110 questions. That means you have, on average, less than 3 minutes per question. That time includes reading the problem, understanding what it's asking, finding the relevant formula in the handbook, plugging in the numbers, calculating the answer, and selecting the right choice. If that sounds intense, that's because it is. So, how do you conquer this beast? You don't just study, you train. You develop a strategy. The first part of that strategy is your calculator. NCEES has a very strict list of approved calculators. You can't just bring your fancy graphing calculator from college. The undisputed king, the weapon of choice for a generation of engineers, is the Texas Instruments TI-36X Pro. Why? Because it's a powerhouse. It can solve systems of equations, perform matrix operations, do numerical integration. It's the closest thing to a magic wand you're allowed to have. Buy it early. Use it for every single practice problem. It should feel like an extension of your own hand. You shouldn't be fumbling for buttons on exam day. It needs to be pure muscle memory. The second and most critical part of your strategy is mastering that reference handbook. Your entire study plan should revolve around it. Don't spend weeks trying to memorize the formula for fluid flow through a pipe. Instead, spend that time doing practice problems and forcing yourself to find that formula in the handbook every single time. Learn to use the search function. Control F is your best friend. But don't rely on it alone. Know that thermodynamics is in one section, and statics is in another. Understand the document's logic. This isn't just about finding things. It's about finding them fast. Shaving 10 seconds off your search time for each question saves you almost 20 minutes over the entire exam. That's enough time to solve 6 or 7 more problems, which could be the difference between a pass and a fail. Let's talk about a realistic study plan. Give yourself 3 months. Anything less and you're cramming. Anything more and you risk burnout. Month 1 is your diagnostic month. Your first mission is to get a copy of the official NCEES practice exam. Book a Saturday, turn off your phone, and take the entire thing under timed conditions. It's going to be brutal. You will feel defeated. That's the point. This isn't about getting a good score. It's about creating a roadmap. When you're done, you'll have a crystal clear picture of your weak spots. Did you bomb the electricity and magnetism questions? Was the statics section a complete disaster? Perfect. Now you know where to focus your energy. For the rest of this month, you will go back to your old textbooks, to YouTube videos, to whatever resources you need, and you will reteach yourself the fundamental concepts in your weakest areas. Don't do 1,000 problems yet. Just rebuild the foundation. Month 2 is the deep dive. This is where you live and breathe practice problems, but you do it with a purpose. You'll use a prep service. Companies like PPI or School of PE offer massive question banks. You will work through problems subject by subject. For every single question, you will have that NCEES reference handbook PDF open. You'll force yourself to find the equations you need. You'll get faster. You'll start to anticipate where things are. You're not just learning engineering. You're learning the map of engineering as defined by NCEES. This is the grind. It's repetitive, it's tedious, but it is the most important part of your training. You are forging the neural pathways that will allow you to perform under pressure on exam day. Month 3 is all about simulation. By now, you should have the concepts down and be comfortable with the handbook. Now, you need to build stamina and perfect your test-taking strategy. You will take at least 2 more full-length timed practice exams. Recreate the testing environment as perfectly as you can. Wake up at the same time you will on exam day. Eat the same breakfast. Use only your approved calculator and a digital copy of the handbook. The strategy you're practicing is called triage. You will make a first pass through each section and answer all the questions you immediately know how to do. The easy ones, the gimmies. Anything that makes you pause for more than 10 seconds, you flag it and move on. After your first pass, you'll go back to the flagged questions. You'll tackle the ones you think you can solve with a little more time. For the problems that are completely alien to you, the ones you know you can't solve, you make your best educated guess and you move on. Do not leave any question blank. This is a game of points, not perfection. Your goal is not to get 100%. Your goal is to pass. The passing score is not a fixed number. It's determined by a statistical analysis of all the test takers. But the general consensus is that you need to be somewhere in the ballpark of 60 to 70% correct. Finally, exam day. You've trained for this. You walk into the testing center. They will scan your palm, take your photo, and check your ID. You'll be led to a small sterile cubicle with a computer. You'll have a laminated booklet and a dry erase marker for your scratch work. You'll take a deep breath, start the tutorial, and then the clock begins. The first half of the exam will fly by. Then comes the scheduled 25-minute break. Take it. Even if you feel like you're on a roll, take the break. Leave the room. Go to the restroom. Splash water on your face. Eat the light snack you brought, something with protein, not sugar. Don't cram or review anything. Just let your brain reset. Then you go back in for the second half. This is where the mental fatigue really sets in. This is where your training pays off. You'll rely on that muscle memory, that mastery of the handbook, that triage strategy you practiced. And then it's over. You'll work until the last second, reviewing flagged questions, making sure every single bubble is filled. You click the submit button, and there's no immediate result. No congratulations, you passed. Just a simple survey about your testing experience. You walk out of that building feeling completely drained, a bizarre mixture of relief and crippling uncertainty. You have no idea if you passed. And for the next 7 to 10 days, you will check your email 100 times a day, waiting for the notification from NCEES. It's an agonizing wait. When that email finally arrives, your heart will pound as you log into the portal. You'll navigate to the results page, and you'll see a single beautiful word: pass. And in that moment, all the struggle, the late nights, the hundreds of practice problems, it all becomes worth it. Because you haven't just passed an exam. You've officially earned your first professional designation. You are now an engineer in training, or EIT. And you've just unlocked the door to the next and most important phase of your journey. This is where the real journey begins. It's a multi-year marathon that separates the graduates from the professionals. This is the crucible. Because having that EIT certificate is like having a key to a car you don't yet know how to drive on the highway. You've proven you understand the physics, the mechanics, the theory. But now you have to prove you can handle it at 70 miles an hour in traffic, in the rain. This phase is all about one thing: gaining qualifying professional experience. And right away, let's shatter the biggest myth out there. The myth is that you just need to work as an engineer for 4 years. That's dangerously wrong. It's not about serving time. It's about earning trust. It's about accumulating a specific kind of experience, under specific conditions, that your state licensing board will recognize as valid preparation for professional practice. Get this part wrong, and you could work for 10 years and still not be eligible to sit for the final exam. So what exactly is this qualifying experience? Think of it as a modern-day apprenticeship. For centuries, a master craftsman would take on an apprentice, not just to teach them a skill, but to guide their judgment, to correct their mistakes, and to ultimately vouch for their competence. Your state board sees this process in the exact same way. And the single most important rule, the golden rule of this entire phase, is that your experience must be gained under the direct supervision of a licensed professional engineer. Let me repeat that, because it is the #1 reason people get their applications rejected. You must work under a PE. Your supervisor, your mentor, the person signing off on your work, must be a licensed PE. Why? Because the state has already put their trust in that PE. They've passed the tests, they've done the time, and they've sworn an oath to protect the public. Now they are extending that trust to you, acting as the board's eyes and ears. They are the ones who will ultimately attest that you have developed the sound engineering judgment necessary to be trusted with the public safety. Now you might be thinking, what if my direct manager isn't a PE? This is an incredibly common scenario. You get a fantastic job offer at a great company, but your team lead, while brilliant, is not a licensed engineer. Do you turn down the job? Not necessarily. But you must be proactive from day one. Your mission is to find a licensed PE within the company. Maybe a department head, a senior technical expert, or a principal engineer, who is willing to formally supervise and review your engineering work for the purposes of licensure. You need to have this conversation early. You need to establish a clear line of mentorship and oversight. If you can't find a single PE in your entire reporting chain who can and will vouch for your work, you are in a danger zone. Your clock, for licensure purposes, has not started. Once you've established that PE supervision, the focus shifts to the nature of the work itself. This is the second major hurdle. The work must show what the boards call progressive responsibility. It means you can't spend 4 years doing the exact same entry-level task. You need to show a clear trajectory of growth. In year 1, you might be performing calculations that someone else has set up for you. You're checking shop drawings, running basic models, or drafting details based on a senior engineer's red lines. You're learning the ropes. By year 2, you should be taking on small, well-defined design tasks yourself. You're not just running the numbers, you're deciding which numbers to run. You're selecting standard equipment, making material choices for a small component, and applying engineering codes to your own work with minimal supervision. By year 3 and 4, you should be responsible for significant portions of a project. You might be leading the design for an entire system, coordinating with other disciplines, communicating directly with clients, and making independent engineering judgments that have real consequences for the project's budget and safety. You're not just following the recipe anymore. You're starting to write it. This progression is critical. The board wants to see that you didn't just occupy a chair for 4 years. They want to see that your PE supervisor progressively trusted you with more complex and critical tasks as your skills and judgment developed. And what are those tasks? The experience must be fundamentally about the application of engineering principles. This is another area where people get tripped up. A lot of jobs have the word engineer in the title, but don't involve the kind of work the board is looking for. So what counts? Things like design, analysis, and evaluation, calculating structural loads for a beam, sizing a pump for a fluid system, developing the control logic for an automated process, performing a fault current analysis for a power system, investigating a component failure, and writing a technical report on the root cause. This is the heart of engineering. What typically doesn't count? Work that is not based on the application of core engineering knowledge. This could be things like pure project management, scheduling, budgeting, and coordinating teams without making technical engineering decisions. It could be sales engineering where your primary role is commercial, not technical design. It could be routine quality control like running the same standardized test over and over. Even pure drafting, where you're just turning someone else's designs into a 3D drawing without any design input yourself, often won't count. These are all valuable skills, but they aren't what the board defines as professional engineering experience. Now, here is the most practical and perhaps most important piece of advice for this entire 4-year period. It's the one thing that will save you from a world of pain when it's time to apply for the exam. Keep a detailed journal of your work. From your very first week on the job, start a document. A simple Word file or a spreadsheet. For every significant project you work on, write it down. Log the project name, the dates you worked on it, and the name of the PE who supervised you. Then, and this is the crucial part, write a detailed paragraph describing your specific role and responsibilities. Don't just say, "I worked on the bridge project." Say, "I was responsible for the hydraulic analysis of the bridge piers. I used HECRAS software to model scour potential under 50-year and 100-year flood conditions, applying principles of fluid dynamics and soil mechanics. I prepared a formal calculation package that was reviewed and approved by John Doe P. Be specific. Use action verbs. Quantify your work whenever possible. This log will become your Bible. 4 years from now, when you're filling out your PE application, you will not remember the details of a project from your first 6 months of work. Your memory will fail you, but your journal won't. Your future self will thank you profusely for the discipline you showed today. This record is the evidence you will submit to prove your experience is legitimate. Finally, remember that every state is its own kingdom. The National Council of Examiners for Engineering and Surveying, or NCEES, provides the exams and a model law, but the ultimate authority is your specific state licensing board. The general requirement is typically 4 years of experience after your bachelor's degree, but some states might allow you to substitute a master's degree or a PhD for 1 or 2 years of that experience. Some states have very specific forms that your PE references need to fill out. Some might require 5 references instead of 3. Your job early in this process is to go to your state board's website, find the requirements for licensure and read them. Read them twice. Understand their specific definition of qualifying experience and their exact documentation requirements. Don't assume. Verify. This 4-year apprenticeship is not a passive waiting period. It is the most active and formative part of your entire career. It's where you transform the theoretical knowledge from college into the practical wisdom of a professional. It's where you learn to balance safety, cost, and function. It's where you make mistakes under the watchful eye of a mentor, so you don't make them when the stakes are real. You enter this phase as an engineer in training. If you are diligent, proactive, and strategic, you will emerge as a true engineer, ready for the final challenge. You've earned your experience, you've documented your journey, and you've proven your worth in the real world. Now only one mountain remains, the 8-hour beast known as the Principles and Practice of Engineering exam. It's a test designed not just to measure your knowledge, but to test your endurance, your problem-solving speed, and your ability to perform under immense pressure. This isn't a college final where you can cram the night before and hope for the best. This is a marathon of the mind, a crucible forged to separate the competent professional from the lifelong student. So what exactly is this 8-hour beast? Let's break it down. The Principles and Practice of Engineering exam, administered by NCEES, is an 80-question multiple-choice test. It's split into 2 distinct halves. The morning session, the first 4 hours, is the breadth section. It covers a wide range of general topics within your chosen discipline. Think of it as a comprehensive survey of your entire undergraduate curriculum. For a civil engineer, this could mean questions on structural analysis, geotechnical engineering, water resources, transportation, and construction management, all in one session. You have to be a jack of all trades. Then, after a 1-hour lunch break, you enter the afternoon session, the depth section. This is where you specialize. You choose a specific focus area within your discipline, And for the next 4 hours, you face questions that dive deep into that subject. If you chose structural depth, you won't be seeing any more questions about traffic flow. You'll be living and breathing steel design, concrete analysis, and lateral forces. This structure ensures that a PE has both a broad understanding of their field and a focused expertise in at least one area. Now, here's the single most important change in the modern PE exam. It's a computer-based test, or CBT. The days of hauling a small library of textbooks into the exam room in a suitcase are over. This isn't an open-book test anymore. It's a closed-universe test. Your only resource during those 8 hours is the official NCEES reference handbook, provided to you as a searchable PDF on the screen. This fundamentally changes the game. Your success is no longer about what you've memorized or which obscure textbook you own. It's about your absolute intimate mastery of that one digital document. You need to know its layout, its terminology, and its limitations better than you know your own hometown. Your ability to quickly search, find, and apply the correct formula or table from that handbook is the primary skill being tested. The true enemy on exam day isn't the difficulty of the questions. It's the clock. You have 480 minutes to answer 80 questions. That breaks down to an average of 6 minutes per question. 6 minutes. In that time, you have to read the problem, understand the question being asked, identify the relevant engineering principles, search the handbook for the necessary equations and data, perform the calculations, check your units, and select the correct answer from 4 options. There is no time to waste. There is no time for self-doubt. You are in a race and every second counts. This realization is the first and most critical mindset shift you must make. You are not training to be a perfect engineer. You are training to be an efficient and effective problem-solving machine. So how do you prepare for a challenge of this magnitude? You build a plan. The widely accepted rule of thumb is that it takes approximately 300 hours of dedicated study to pass the PE exam. For most people working a full-time job, this translates to about 15 to 20 hours a week for 4 to 6 months. It's a serious commitment. Your journey begins with a dose of humility. The very first thing you should do before you study a single page is take a full-length diagnostic practice exam. It's going to be brutal. You will feel rusty, you will get a low score, and your confidence will take a hit. This is the point. This initial test isn't for a grade. It's for data. It will expose your weaknesses with surgical precision and give you a raw, honest baseline. It tells you exactly where you need to focus your energy for the next few months. With your weaknesses identified, the first phase of your study plan is about rebuilding your foundation. You'll spend the first month or so revisiting the core concepts from your breadth topics. Dust off those old college textbooks. Watch online tutorials. You need to relearn the language of a field you may not have touched in years. This phase isn't about speed. It's about comprehension. Phase 2 is the grind. This is the heart of your preparation, typically lasting 2 to 3 months. Your life will become a cycle of work, study, eat, sleep, repeat. Your focus here is singular. Practice problems. Hundreds of them. Thousands of them. You should be solving problems every single day. This is how you develop pattern recognition. You'll start to see how NCEES frames their questions, the common tricks they use, and the specific information they expect you to pull from the handbook. And speaking of the handbook, during this phase it becomes your Bible. You should have it open for every single problem you solve. Learn its chapter structure. Understand its search function's quirks. Use the bookmark feature to create quick links to your most used tables and charts. You want to get to a point where you can navigate that PDF with pure muscle memory, finding what you need in seconds, not minutes. The phrase Control F will become your mantra. The final phase, in the last month before the exam, is all about simulation and refinement. This is when you start taking full-length, 8-hour timed practice exams under realistic conditions. Lock yourself in a quiet room. Turn off your phone. Use only the NCEES handbook. This builds the mental and physical stamina required to survive the actual test day. It's one thing to solve problems for an hour or 2. It's another thing entirely to maintain focus and accuracy in hour 7 when your brain feels like mush. After each practice exam, you must perform a ruthless post-mortem. Create a mistake log. For every single question you got wrong, write down why you got it wrong. Was it a calculation error? Did you misread the question? Did you use the wrong formula? Did you simply run out of time? This log will become one of your most valuable study tools, allowing you to patch the specific holes in your process. In the final week, you stop learning new material. The hay is in the barn. Cramming now will only lead to burnout and anxiety. Your focus shifts to light review, looking over your mistake log, and most importantly, resting. You need to walk into that testing center with a mind that is sharp, clear, and calm. Of course, you don't have to do this alone. There is a massive industry of prep materials and courses. The official NCEES practice exams are non-negotiable. You must buy them and solve them. They are the closest you will get to the real thing. Beyond that, you have options. Companies like PPI, School of PE, and others offer comprehensive review courses with video lectures, binders full of notes, and massive question banks. These can be incredible resources, but they are also a significant financial investment. The alternative is a do-it-yourself approach, piecing together your study plan with textbooks, problem manuals, and online resources. It's a cheaper path, but it requires more discipline and self-direction. Finally, the day arrives. You'll wake up early, eat a good breakfast, and drive to a sterile, quiet Pearson VUE testing center. You'll go through a security check that feels like you're at an airport. They'll scan your ID, take your picture, and check your glasses for hidden cameras. You'll be assigned a small locker for your belongings, because nothing is allowed in the testing room except you and your ID. You'll be led to a small cubicle with a computer. You'll sit down, the proctor will log you in, and a timer on the screen will begin to count down from 8 hours. And in that moment, everything else fades away. It is just you, the screen, and the challenge you've spent months preparing for. You'll feel the adrenaline, the nerves, the focus. You'll start clicking through the questions, flagging the ones you're unsure of, managing your time, fighting back fatigue, and trusting in your preparation. Then, after what feels like both an eternity and the blink of an eye, you'll answer that final question. You'll take a deep breath, review your flagged items, and with a final definitive click, you will submit your exam. A wave of pure exhaustion and profound relief will wash over you. You'll walk out of that testing center, blinking in the sunlight, feeling like you've just run a marathon. The fight is over, but the ordeal is not. Now the hardest part of all begins, the wait. The agonizing, soul-crushing week of silence before a single email appears in your inbox. An email that contains one simple word that will change the entire trajectory of your professional life. That word is passed. It appears in plain black sans serif font. No fireworks, no confetti, no congratulatory banner. Just a single 7-letter word that feels like the weight of a mountain being lifted from your shoulders. The breath you didn't even realize you were holding for a week escapes in a rush. The tension in your neck, the knot in your stomach, it all just dissolves. You read it again and again. You close the browser, reopen it, log back in just to make sure it wasn't a glitch, a phantom from your sleep-deprived imagination. But there it is, solid and real. Passed. This is the moment. This is the validation for the all-nighters in college, the thousands of dollars in tuition, the 4 years of grinding through problem sets, and the hundreds of hours you just spent studying for an 8-hour marathon of an exam. It's an incredible, intoxicating feeling of victory. But the celebration, as glorious as it is temporary. Because passing the P exam is like climbing to the false summit of Mount Everest. You've conquered a monumental challenge, and the view is amazing. But as the adrenaline fades, you look up and realize you're only halfway there. There's another, equally imposing peak you still have to summit. This second peak isn't a single brutal 8-hour event. It's a 4-year odyssey, a 1,460-day trial by fire. It is, of course, your qualifying engineering experience. And this is where so many aspiring engineers get it wrong. They think the experience requirement is just a waiting period, a countdown clock. You graduate, you get a job, you punch the clock for 4 years, and then you get your license. That is a dangerously flawed assumption. The state licensing board doesn't just want to know that you've been employed for 4 years. They want to know that you've been practicing engineering for 4 years. And there is a world of difference between the two. Think of your PE application not as a form, but as a legal case. You are the attorney, and your career is the client. The state board is the judge and jury. Your mission is to present a mountain of irrefutable evidence proving, beyond a reasonable doubt, that you possess the character, the knowledge, and the judgment to be entrusted with the public's safety. The P exam was your bar exam. Now, you have to prove your case history. So what constitutes qualifying experience? While the exact wording varies from state to state, the core principles are universal, and they boil down to 3 pillars. First, the application of technical knowledge. This is the foundation. You have to show that you were doing actual engineering work. This means design, analysis, calculation, and problem solving. It's not enough to say you worked on the bridge project. What did you do? Did you perform the hydraulic analysis for the pier scour? Did you design the steel girder connections according to AASHTO specifications? Did you use software like RISA 3D or STAAD.Pro to model the structural loads and verify the design? You need to describe the specific engineering codes, standards, and principles you personally applied. Managing budgets and schedules is important work, but it is not, in the eyes of the board, qualifying engineering experience. Second, progressive responsibility. This is the narrative arc of your career. The board needs to see growth. They want to see that you didn't just do the same entry-level task for 4 years straight. Your story needs to show you evolving from someone who receives tasks to someone who manages them, and eventually, to someone who defines them. Imagine your first year. You're fresh out of school, a rookie. You're likely doing component-level design, running calculations that are checked and double-checked by a senior engineer. You're drafting details in CAD, reviewing shop drawings, and basically acting as a force multiplier for the PE in charge. This is your foundation. By year 2, you should be taking on small, well-defined projects of your own. Maybe you're responsible for the entire stormwater management design for a small commercial site. You're not just crunching numbers someone gave you. You're making initial design decisions, albeit under close supervision. By year 3, your scope expands. You're now a project engineer. You're coordinating with other disciplines, architects, surveyors, geotechnical engineers. You're writing technical specifications. You might be mentoring an intern or a fresh EIT. You're not just a calculator anymore. You're a hub of technical coordination. By year 4, you should be operating at a near PE level. You might be the engineer of record for non-critical project components, with your work reviewed and sealed by your PE supervisor. You're making significant technical judgments, presenting them to clients and defending them. You are leading the technical direction of projects. This progression is the story you must tell. From apprentice to journeyman, on the cusp of becoming a master. The third and most important pillar is engineering judgment. This is the secret ingredient. The board is looking for evidence that you can make sound decisions in the face of incomplete data, conflicting requirements, or technical uncertainty. This is what separates a professional engineer from a highly skilled technician. A technician can follow a codebook perfectly. An engineer knows what to do when the codebook doesn't have the answer. You have to document these moments. The time you had to choose between 2 viable but flawed foundation designs, and you had to perform a risk analysis to recommend the best path forward. The time a contractor proposed a value engineering alternative, and you had to analyze it from a technical and safety standpoint, ultimately rejecting it because it compromised the long-term integrity of the structure. The time you identified a critical flaw in a senior engineer's design, and you had the courage and the technical evidence to bring it up, leading to a safer, better project. These are the golden nuggets for your application. These are the stories that prove you are ready. So how on earth do you remember all of this 4 years later? You don't. You can't. Your memory will fail you. This is why the single most important habit you can build as an EIT is keeping a detailed, weekly work journal. This isn't a diary. It's a logbook, a record of evidence. Every Friday afternoon, take 15 minutes. Open a simple Word document or a spreadsheet. Write down the project names you worked on that week. For each one, list the specific tasks you performed. Don't just write, did drainage design. Write, performed hydrologic analysis for the 100-year storm event on the Oak Street project using the TR55 method. Size the detention basin and outlet structure to meet local municipal code requirements for peak flow reduction. Note the challenges you faced and the decisions you made. Encountered conflicting utility survey data. Initiated a field investigation and coordinated with the surveyor to resolve the discrepancy, preventing a potential utility strike during construction. Over 4 years, this document will become your Bible. It will transform the daunting task of writing your experience record from an exercise in creative writing and vague recollections into a simple, straightforward process of compiling and editing your meticulously recorded history. Your future self will thank you profusely. You have the exam pass. You have the 4 years of meticulously documented, qualifying experience that shows technical application, progressive responsibility, and sound engineering judgment. You've climbed both peaks. Now all that's left is to put it all together, to craft the narrative, secure your references, and submit the final application to the state board. But there's one final gatekeeper. One person whose signature is the final mandatory key to unlocking your license. A person who has watched your entire 4-year journey, who has guided you, taught you, and who ultimately holds veto power over your entire application. Your direct PE supervisor. and convincing them to sign off on your experience, well, that's a conversation that can define your entire career. This conversation isn't about asking for a favor. It's not like asking someone to help you move a couch. This is a formal request for a senior professional to stake their own license, their reputation, and their personal liability on your competence. When a professional engineer signs your experience record, they are making a legally and ethically binding statement to the state board and to the public that you are ready to be trusted with public safety, ready to make decisions that could impact thousands of lives, ready to uphold the highest standards of the profession. So when you walk into that office, you're not just carrying a form. You're carrying the weight of that responsibility, and you're asking them to share it. Before you even schedule that meeting, you need to understand the psychology of the person on the other side of the desk. What are they thinking? Their primary concern is not you. It's not your career, it's not your feelings. Their primary concern is protecting the public, and by extension, protecting their own license. Every year, PS have their licenses suspended or revoked for misconduct, and a surprising number of those cases involve improperly verifying the experience of an applicant. They are putting their entire livelihood on the line by signing that paper. They are attesting under penalty of perjury that your experience is true, accurate, and of a professional engineering-specific nature. If you mess up 5 years from now, and an investigation reveals that your foundational experience was questionable, their signature on your application could come back to haunt them. It's a huge ask. So your job is to make it the easiest, most comfortable, and most obvious yes they will ever give. How do you do that? You don't start with the conversation. You start months, even years before. You start by building a fortress of documentation. Your greatest tool in this entire process is your work experience record, and it needs to be a masterpiece of clarity, detail, and irrefutable evidence. Do not, under any circumstances, show up with a blank form and say, "Hey, can you help me fill this out?" That's the kiss of death. It shows a lack of preparation and puts the entire burden on them. Instead, you present them with a meticulously crafted, practically finished document. Your experience record should read like a story of your professional evolution. For every project, for every role, you need to be specific. Don't just say, "I designed a drainage system." That's useless. Say, "I performed hydrologic and hydraulic analysis for the 15-acre commercial site at 123 Main Street, using HCRAS to model the 100-year storm event. I designed a detention basin, sized all culverts in accordance with state DOT standards, and prepared the final construction drawings and specifications, which were approved by the city engineer." See the difference? One is a vague claim. The other is a verifiable statement of engineering work. Use the STAR method as your guide for every entry. Situation, task, action, result. What was the project? What was your specific assignment? What exact engineering actions did you take? And what was the outcome? Did you save the client money? Did you solve a complex technical problem? Was your design built and is it functioning today? Quantify everything you can. Instead of assisted with project management, Wright managed a $50,000 budget for the geotechnical investigation phase, coordinating with 2 subcontractors and delivering the final report 2 days ahead of schedule. This level of detail does 2 things. First, it makes it easy for your supervisor to recall the work and confidently sign off. Second, it shows the state board that you weren't just a spectator. You were an active, contributing engineer making real decisions. You should be keeping a detailed journal of this information from day 1 of your career. A simple spreadsheet. Date, project, task, outcome. Update it weekly. When it's time to apply for your license 4 years later, you won't be struggling to remember what you did on a Tuesday morning in 2021. You'll have a mountain of data ready to be refined into your application. Once your documentation is bulletproof, it's time to plan the conversation. Timing is critical. Don't ambush your supervisor on a frantic Monday morning or right before a major project deadline. That's just disrespectful of their time and pressure. Ask their assistant, or them directly. If you can schedule 30 minutes to discuss your professional development and your PE application, this signals that it's an important, formal conversation, and it gives them time to prepare mentally. When you walk into that room, you are in control. This is your career. Start with gratitude. Thank them for their mentorship and the opportunities they've given you. This isn't just flattery. It's a genuine acknowledgement of their role in your journey. Then state your purpose clearly. As you know, I've been working towards my PE license for the past 4 years, and I'm now preparing my application for the state board. I've completed the experience portion of the application, detailing the work I've done under your supervision, and I would be honored if you would review it and consider endorsing it. Then, you place the beautifully prepared document in front of them. Don't just hand it over and wait. Guide them through it. I wanted to specifically draw your attention to the Acme Warehouse project on page 2. You'll see I detailed my work on the steel frame analysis, specifically the moment connection designs I was responsible for. And on page 3, the downtown bridge retrofit, where I performed the seismic calculations we discussed. You are proactively refreshing their memory, connecting the dots for them, and demonstrating your thoroughness. You've done the hard work for them. All they have to do is read and agree. Be prepared for questions. They might challenge you on a detail. I thought Sarah handled the primary seismic calcs on that project? Don't be defensive. Be precise. That's right, Sarah was the lead, and she handled the overall structural analysis. My specific role as the EIT on her team was to perform the calculations for the non-structural component anchorage, which I've detailed here. A good supervisor will grill you. They are testing you. They want to be sure you truly understand the work you're claiming. Welcome these questions. Acing them is the final proof that you're ready. Now, what happens if they say no? Or more likely, I don't think you're ready yet. Can feel like a punch to the gut. Years of work, all leading to a rejection. But your reaction in this moment is what separates a professional from an amateur. Do not argue. Do not get emotional. You look them in the eye and say, "Thank you for your honest feedback. It's incredibly valuable to me. Could you help me understand which areas of my experience you feel are weakest? And what kind of projects or responsibilities I should seek out over the next 6 to 12 months to get there?" This response is a game changer. You've turned a devastating no into a concrete action plan. You've shown maturity, respect for their opinion, and a commitment to improvement. You've just transformed your supervisor from a gatekeeper into a dedicated ally in your success. They now have a vested interest in helping you fill those gaps so they can sign for you in the future. Of course, there's the nightmare scenario. Your PE supervisor left the company 2 years ago. This is more common than you'd think. Your first step is to become a private investigator. Use LinkedIn, use your company's alumni network, call old colleagues. Find them. Most PS understand the situation and will be willing to help if you approach them professionally. Reintroduce yourself, remind them of the projects you worked on together, and send them your pre-filled experience record. If you absolutely cannot find them, or they refuse to sign, you're not doomed. Most state boards have a process for this. It usually involves getting a notarized affidavit from a coworker and a detailed letter of explanation. You might need to get a signature from another PE at your old company who has access to the project records and can verify your involvement, even if they didn't directly supervise you. It's more paperwork, it's a headache, but it's a solvable problem. The key, as always, is meticulous documentation. When you get that signature, whether it's on the first try or after a year of targeted effort, it is a monumental milestone. It's more than just ink on paper. It's a rite of passage. It's the official endorsement from a member of the professional tribe, declaring that you are one of them. It's the validation of 4 years of long hours, complex problems, and relentless learning. With that signature in hand, the final gate is in sight. You've proven your education. You've passed the first marathon exam. And now, your real-world experience has been officially certified. All that's left is the final boss. The Principles and Practice of Engineering exam. The Principles and Practice of Engineering exam. The P. This isn't just another test. This is the culmination. If the FE exam was about proving you had the academic foundation of an engineer, the PE exam is about proving you can think like one. It's the final barrier, the one that separates the engineer in training from the professional engineer. It's a test of judgment, experience, and the ability to perform under pressure. It's designed to simulate the demands of a real engineering career, where the answers aren't in the back of the book, and the consequences are real. The biggest mental shift you have to make from the FE to the PE is the scope. The FE was a mile wide and an inch deep. It tested your general knowledge across a vast landscape of engineering topics you learned in college. The PE is the opposite. It's an inch wide and a mile deep. It dives into the specific, practical knowledge of your chosen discipline. This exam assumes you know the fundamentals. Now it wants to know if you can apply them to complex, real-world scenarios. It's no longer about memorizing formulas. It's about knowing which formula to use, when to use it, and how to interpret the results in the context of a project. It's about understanding codes and standards, weighing alternatives, and making sound engineering judgments. Your first major decision in this final stage is choosing your weapon, your exam discipline. NCEES offers PE exams in a wide range of fields: civil, mechanical, electrical and computer, chemical, environmental, and many others. This choice is critical. You must select the exam that most closely aligns with the 4 years of progressive engineering experience you just painstakingly documented. If you've spent your career in HVAC design, taking the mechanical PE with a focus on HVAC and refrigeration is your path. If you've been designing roadways and drainage systems, the civil PE with a focus on transportation or water resources is your arena. This isn't the time to get nostalgic for that one thermodynamics class you loved in college if you've been working in structural engineering for 4 years. Your experience is your greatest asset, and the exam is designed to test that very experience. So you'll head to the NCEES website, review the specifications for each discipline, and pick your specialization. This choice will define the rest of your preparation and, in many ways, will solidify your professional identity. Once you've chosen your discipline, you need to understand the structure of the beast you're about to face. The PE exam is a grueling 9-hour appointment. That includes a tutorial, a break, and 8 full hours of testing time. It's a computer-based test, or CBT, administered at Pearson VUE testing centers. This means no more giant binders and rolling suitcases full of books like in the old days. Everything you need is on the computer. The exam is typically split into 2 4-hour sessions. For many of the larger disciplines like civil engineering, this takes the form of a breadth and a depth section. The morning breadth section covers general knowledge from all the major areas within your discipline. A civil engineer, for example, will see questions from structural, geotechnical, water resources, transportation, and construction regardless of their specialty. It ensures you have a competent, well-rounded understanding of your entire field. Then the afternoon depth section is where you zero in. This is where you prove your expertise in the specific area you chose when you registered, like structural or geotechnical. These questions are more complex, more involved, and require a much deeper level of knowledge. You're no longer a generalist. You are a specialist solving problems in your domain. Now let's talk about the single most important tool you'll have on exam day: the NCEES Applied Reference Handbook. This is an electronic, searchable PDF document that will be available on your screen during the entire exam. This is a game changer from the old paper and pencil, bring your own books format. Your success on the PE exam is not about what you can memorize, but how efficiently you can find and apply the information within that handbook. It contains thousands of pages of formulas, tables, charts, and code excerpts. Mastering this document, knowing its layout, its terminology, and how to use the search function to find what you need in seconds, not minutes, is arguably the most important skill you will develop while studying. The questions themselves are designed to be tricky. They are not straightforward plug-and-chug problems. They are designed to mimic real engineering tasks. You'll be presented with a scenario, a set of plans, or a client's problem statement. A question might ask you to calculate the required rebar in a concrete beam, but it won't just give you the numbers. You'll have to pull the beam dimensions from a drawing, find the material properties from a table, determine the correct load factors from a code section, and then select the appropriate formula to perform the calculation. Many questions are what they call alternative item types, or AITs. These go beyond simple multiple choice. You might have to drag and drop labels onto a diagram, select multiple correct answers from a list, or fill in a blank with a calculated value. This format forces you to truly understand the problem and come to a definitive answer. You can't just guess your way through it. They are testing your ability to synthesize information from multiple sources to arrive at a single correct engineering solution, just like you would on the job. So, how do you prepare for such a monumental challenge? You don't cram, you train. Preparing for the PE exam is a marathon. Most successful candidates put in around 300 hours of dedicated study over a period of 3 to 6 months. This isn't something you can knock out in a few weekends. This is a part-time job on top of your full-time job. Your study plan should have several key components. First, get a copy of the NCEES PE Reference Handbook for your discipline on day 1. This is your Bible. Every problem you solve, every concept you review should be done with an eye toward how you would look it up in the official handbook. Second, invest in a dedicated review course. While you can self-study, a structured course from a reputable provider like PPI or School of PE can provide an invaluable roadmap. They've dissected the exam, they know the high probability topics, and they provide structured lessons, homework, and practice quizzes to keep you on track. It's a significant financial investment, but it pales in comparison to the cost of failing and having to start the process all over again. Third, and most importantly, practice problems. Hundreds of them. Thousands of them. The single best source of practice is the official NCEES practice exam. This is written by the same people who write the real exam. It is the most accurate representation of the difficulty, format, and style of questions you will see on test day. You must take this practice exam, and you should do it under timed exam-like conditions. This builds your mental stamina and exposes your weak areas. Your study schedule should be disciplined. Maybe it's 2 hours every weeknight and 6 hours on Saturday. Whatever it is, you must stick to it. You start by reviewing the fundamental concepts, then you start working practice problems untimed at first just to master the mechanics. As you get closer to the exam, you shift to timed practice. Can you solve this type of problem in the average time allotted, which is about 6 minutes per question? You'll create a brain dump sheet of critical formulas and concepts you need to recall quickly. You'll tab your physical copy of the handbook for quick reference during study, knowing you'll have to rely on the search function in the real thing. Finally, you have to prepare for the day itself. The logistics, the psychology. You'll visit the testing center beforehand if you can, just to know the route and the environment. You'll plan your meal for the 45-minute lunch break. The night before, you won't cram. You'll relax. You'll get a good night's sleep. You'll walk into that testing center not with fear, but with the quiet confidence of someone who has put in the work. You'll sit down at that computer, take a deep breath, and begin the final 8-hour push that stands between you and everything you've worked for. You will manage your time, flag difficult questions to come back to later, and trust in your preparation. And when that timer finally runs out, or when you've answered that last question and reviewed it one final time, you'll take another deep breath, move the cursor over the submit button and click. And then the wait begins. That short walk from the testing center door to your car is one of the strangest experiences of the entire process. The world looks the same, but you feel fundamentally different. There's a profound sense of emptiness where that constant low-grade exam anxiety used to live. For months, maybe even years, your brain has been dedicated to this single monumental task. And now it's over. The silence is deafening. You'll probably sit in your car for a few minutes, just staring blankly at the steering wheel. A wave of exhaustion, deeper than any you've felt before, will wash over you. It's not just physical tiredness. It's a profound mental and emotional fatigue. You'll feel a sense of relief, yes, but it's tangled up with uncertainty. You'll start replaying questions in your head. That one about fluid dynamics. Did I use the right equation? The ethics question with the tricky wording. Was I supposed to choose B or C? You'll second-guess yourself, then tell yourself it's pointless, then do it all over again. This is the purgatory of the post-exam mind. For the computer-based exams, the official wait time for results is typically 7 to 10 business days. Sounds short, but it will feel like a geological epoch. The first day or two, you'll probably just sleep, decompress, and try not to think about it. You'll reconnect with the family and friends you've been neglecting. You'll watch a movie without feeling guilty that you should be studying. Feels good. But then, around day 3 or 4, the anxiety starts to creep back in. Every time your phone buzzes with an email notification, your heart will leap into your throat. You'll start compulsively checking your NCEES account, hitting refresh over and over, even though you know it's too early. You'll scour online forums, looking for other people who took the exam on the same day as you. Anyone from the Tuesday Civil Structures group get their results yet? You'll see posts from people who passed, and you'll feel a surge of hope. You'll see posts from people who failed, and a knot of dread will tighten in your stomach. And then, one morning, it's almost always a Wednesday morning for some reason, it will happen. You'll be at work, sipping your coffee, trying to focus on a spreadsheet when the email arrives. The subject line is simple, clinical, and utterly terrifying. NCEES exam results are available. Time will seem to slow down. Your breathing will get shallow. This is it. The culmination of 4 years of college, 4 years of work experience, and hundreds of hours of studying is waiting for you behind a single login screen. You'll take a deep breath, navigate to the NCEES website, and type in your username and password with trembling fingers. You'll click Login. The page loads, and you see it. Let's talk about the best-case scenario first. You scan the page, your eyes darting around, and then you see a beautiful, glorious 4-letter word in bright green text. Pass. The feeling is impossible to describe, but I'll try. It's not just happiness. It's an explosion of relief so potent it almost feels physical. Like a massive weight, you didn't even realize you were carrying has been lifted off your entire being. You might let out a shout. You might burst into tears. You might just sit there, staring at the screen in stunned, euphoric silence. You'll read the word pass again and again, just to make sure your eyes aren't deceiving you. All the sacrifice, the late nights, the weekends spent with textbooks instead of friends, the moments of crippling self-doubt. In that instant, every single second of it becomes worth it. You did it. You climbed the mountain. You are going to be a professional engineer. But there is another possibility, and we have to talk about it. Because for many good, smart, capable engineers, the journey doesn't end here. You log in, the page loads, and instead of green, you see a stark, brutal four-letter word in red. Fail. It's a gut punch. A wave of crushing disappointment washes over you. Feels personal. It feels like a judgment on your intelligence, on your worth as an engineer. All that work, all that sacrifice for nothing. It's a deeply painful and isolating moment. And it is absolutely okay to feel devastated. It's okay to be angry, to be sad, to feel like giving up. Allow yourself to feel those things. But after you've processed that initial shock, I want you to do something very important. Look closer at your results page. NCEES provides you with a diagnostic report. This report is your single most valuable tool. It's not just a failing grade, it's a roadmap. It breaks down the exam by subject area and shows you how you performed on each one. It will show you your score on topics like geotechnical engineering, or transportation or power systems, and compare it to the average score of the passing candidates. You'll see your areas of weakness laid out in black and white. Maybe you were brilliant on the structural questions but struggled with water resources. Maybe your knowledge of project management was thin. This report isn't a judgment. It's data. It transforms a feeling of "I'm not smart enough" into a concrete, actionable plan. I need to focus more on hydrology and hydraulics next time. It's the guide that will lead you to a pass on your next attempt. Failure is not a reflection of your potential. It is simply a delay in your timeline, and it comes with a personalized study guide for your next round. Now let's go back to the celebration. You passed. You've called your spouse, your parents, your mentor. You've shared the news with your boss, who is probably already thinking about your new billing rate. You feel like you're on top of the world. But I have to tell you something critical. Passing the PE exam does not make you a PE. Let me say that again. Passing the exam is the single largest hurdle, but it is not the finish line. It means you are now eligible to apply for licensure with your state board. You've proven your technical competency. Now you have to prove everything else. This is where the final and often most frustrating phase of the process begins: the formal application. Remember all that paperwork you started preparing months ago? Your detailed work experience, your references, your college transcripts? It's time to assemble it all into one comprehensive package. You'll go to your state licensing board's website, download the official application for licensure by examination, and begin the meticulous process of filling it out. This isn't just a formality. The board will scrutinize every single part of your application. They will read your experience descriptions to ensure they meet the state's definition of progressive engineering responsibility. They will contact your references to verify your character and competency. They will cross-reference your NCEES record to confirm your exam pass and your FE exam date. Any mistake, any missing document, any discrepancy can send your application to the bottom of the pile, potentially delaying your license by months. You've slain the dragon of the PE exam. You've earned your victory. But now you stand before the final gatekeeper, the state bureaucracy. Navigating this web of forms, requirements, and regulations is a different kind of test. One that requires patience, attention to detail, and a clear understanding of the rules. This is the final administrative sprint that stands between you and the right to add those two powerful letters after your name. So let's break down this final sprint. You've conquered the beast that is the principles and practice of engineering exam. You've proven your technical mastery. But now the State Board of Licensure asks a different question. Are you a professional? And they don't just take your word for it. They want proof, documented with the kind of precision and clarity they expect from a licensed engineer. This is the paper chase, the final gauntlet of forms, signatures, and verifications. First, you'll face the application packet itself. In some states, it's a sleek online portal. In others, it's a daunting PDF document that feels like it was designed in 1995. Regardless of the format, treat it with the reverence of a legal document, because that's exactly what it is. This is your formal petition to join an honored profession, and every single field matters. A single missed signature, a transposed date on your work history, an unchecked box. These are the kinds of simple errors that can send your application right back to you, delaying your license by weeks or even months. Read the instructions, then read them again. Then have a trusted colleague read them. The level of detail required here is your first demonstration to the board of your meticulousness as an engineer. Now let's talk about the heart of the application, the section that will receive the most scrutiny: your detailed experience record. This is not a resume. A resume is a marketing document designed to get you an interview. Your experience record is a legal testament, a sworn statement of your qualifying engineering work, verified under penalty of perjury. It's your engineering autobiography, and it needs to be written with absolute clarity. The board is looking for one thing above all else: evidence of progressive engineering experience that demonstrates increasing levels of responsibility and judgment. They need to see that you haven't just been doing the same entry-level tasks for 4 years. They need to see a story of growth. You need to show them, not just tell them. Assisted on bridge design projects is a terrible entry. Tells the board nothing. What did you do? What principles did you apply? What was the scale? What was the outcome? A powerful entry sounds more like this: performed structural analysis and design for a 350-foot, 3-span, pre-stressed concrete girder bridge. I was responsible for calculating the dead and live loads according to AASHTO specifications, designing the reinforcement for the concrete deck, and creating detailed construction drawings using AutoCAD. My analysis contributed to a design that was completed on schedule and 5% under budget. See the difference? The second example is specific. It uses engineering language. It details your direct responsibilities, references codes and standards, and where possible, it quantifies the results. You're not just listing tasks, you're building a case. You are the lawyer and your career is the client. Your job is to present irrefutable evidence that you have been working at the level of a professional engineer. Structure your experience record chronologically. For each position, describe the company and your role, then break down your key projects. For each project, explain the engineering problem, the actions you personally took, the engineering principles you applied, and the results of your work. Think of it as a series of mini-project reports. This is your chance to showcase your technical skills, your project management abilities, and your understanding of the bigger picture. Don't be shy, but be ruthlessly honest. Exaggeration is the enemy and can lead to an outright rejection. Once you've painstakingly crafted this narrative of your career, you need to assemble your champions. These are your references. Again, this is far more than just listing a few names and phone numbers. The board requires a specific number of references, and most, if not all, of them must be licensed professional engineers who have direct personal knowledge of the work you're claiming. They are not just character witnesses, they are professional verifiers. Choosing your references is a strategic decision. Your direct supervisor, a licensed PE, is usually your strongest reference. A senior PE from another department who mentored you on a major project is another excellent choice. A client, if they are a PE, can offer a powerful and unique perspective. The key is that they must be able to speak with authority about the specific work you described in your application. A PE who is a family friend but has never seen your work is useless to the board, and how you approach them matters. Do not just email them a link and say, "Hey, can you fill this out?" This is a massive professional favor. Call them first. Explain that you're applying for your PE license and ask if they would be willing to serve as a reference. If they agree, make their job as easy as humanly possible. Send them a single, organized package. Include a polite cover letter, a copy of the experience record you wrote, the specific reference forms pre-filled with your information, and a stamped, addressed envelope if it's a paper submission. By giving them your detailed write-up, you're not telling them what to say. You're refreshing their memory of the incredible work you did together, ensuring their account aligns with yours. Follow up politely a week or two before the deadline, just to make sure they haven't forgotten. Remember, their time is valuable, and your professionalism in this process reflects on you. With your application filled out and your references secured, there's often one more hurdle: the state-specific ethics and jurisprudence exam. Don't underestimate this. It's typically an open book test, but that doesn't mean it's easy. This exam tests your knowledge of the state's specific engineering laws, rules, and codes of conduct. It's the board's way of ensuring you understand the legal and ethical framework you are about to operate within. They want to know, do you understand your primary obligation is to the public's health, safety, and welfare? Do you know the rules about stamping and sealing documents? Do you understand the line between professional promotion and deceptive advertising? This exam is the final gatekeeper of character. The P exam proved you were technically competent. The ethics exam proves you can be trusted with the immense responsibility that comes with the license. Study the materials they provide. Take it seriously. It's the last test standing between you and your goal. Finally, with everything compiled, checked, and double-checked, you hit submit or mail that thick envelope. You've done it. You've sent your entire early career, distilled into a stack of paper, off to a group of strangers for judgment. And then you wait. This waiting period can be one of the most agonizing of your life. Can take anywhere from a few weeks to several months. During this time, your application is undergoing a meticulous review. It's first checked by administrative staff for completeness. Then it's passed on to the board members themselves, a committee of senior professional engineers from various disciplines who volunteer their time. They are your peers. They have been in your shoes. They will read your experience record. They will review your references statements. They will scrutinize every detail, looking for the clear, unmistakable track record of a competent and ethical engineer. They aren't trying to fail you. They are guardians of the profession, and their job is to ensure that everyone who is granted the title of professional engineer is truly worthy of the public's trust. And so you wait, checking your email a dozen times a day, your heart skipping a beat every time you see a letter in the mail with the state's official seal. Every day that passes is a day closer to knowing you've put in the years of school, the long nights of studying, the 4 years of dedicated work, the marathon exam, and the sprint of paperwork. Everything you've worked for comes down to a single notification, a simple verdict from the board. That one email, that one letter, holds the key to the future you've been building block by block, calculation by calculation, for the better part of a decade. And then one day it arrives. The email subject line is deceptively simple: your NCEES exam results. Your heart hammers against your ribs. You might stare at it for a minute or an hour, afraid to click. Because in that single click, the ambiguity that you've lived with for weeks will vanish, replaced by a brutal binary outcome. Pass or fail. There is no in-between. You take a breath, you click the link, you log in. The page loads with agonizing slowness. And then you see it. A single word. For some, it's the crushing blow of fail. A sign that the battle isn't over. That more sacrifice is required. It's a moment of profound disappointment. A test of resilience that feels almost unfair after everything you've endured. But for others, the word that appears on the screen is pass. Doesn't feel real at first. You read it again. And again. The letters seem to float, disconnected from a meaning you've craved for years. And then it sinks in. A wave of relief so powerful it almost brings you to your knees. It's not just happiness. It's the sudden, breathtaking release of years of accumulated pressure. The late nights studying, the weekends you sacrificed, the family events you missed, the constant, nagging voice of self-doubt. It all evaporates in an instant. You've done it. You climbed the mountain and are finally standing at the summit. This moment is the culmination of the entire journey. But passing the exam is not the final step. It's the final gate. Now you have to walk through it. The official notification from your state board comes next, congratulating you and inviting you to formally apply for licensure. This involves a final round of paperwork, the formal application, attestations of your character, and of course a final fee. For many states, this is also when you take a separate ethics and jurisprudence exam, a test focused not on technical formulas, but on the laws and rules that govern the profession in your specific state. It's the state's way of ensuring you understand the legal gravity of the authority you're about to be granted. Once your application is approved, you are no longer an engineer in training. You are an engineer. The board issues you a license number, a unique identifier that is yours and yours alone for the rest of your professional life. And then comes the ceremony. Some states hold formal events where new PS take an oath, reciting the engineer's creed, publicly pledging to uphold the highest standards of honesty and integrity. It's a powerful moment, standing in a room with your peers, formally accepting the mantle of the profession. But perhaps the most tangible symbol of this transformation is ordering your first PE stamp. You go to an office supply website, you type in your name, your state, and your new license number, and a few days later a small heavy object arrives in the mail. It might be a rubber stamp with a wooden handle, or a metal embosser. You press it onto an ink pad, and then onto a blank piece of paper. And there it is. Your name inside a circle, with the words professional engineer. It's a profound moment. This small object is the physical embodiment of your authority. It is a key that unlocks the highest levels of the engineering profession. So what actually changes? The day after you get your license, the world looks the same. But professionally, everything is different. The letters P after your name are not just a vanity title. They are a legal designation. They signify that you have the legal authority to sign and seal engineering drawings and documents, to take final responsibility for a design. Before, you could do the work, but a licensed PE had to review and approve it. Now you are that person. You are the engineer of record. When a bridge is built, a skyscraper is erected, or a new water treatment plant goes online, it is your seal on those plans that certifies to the world that the design is safe for public use. This is the true weight of the license. It's not just about a promotion or a pay raise, though those often follow. The average salary for a PE is significantly higher than for their unlicensed counterparts, and many senior and management positions are exclusively open to licensed engineers. The PE license is the prerequisite for career advancement into roles of leadership and ultimate authority. It gives you the credibility to serve as an expert witness in a court of law. It gives you the legal standing to open your own engineering consulting firm and be your own boss. It transforms you from an employee executing a task to a professional rendering a judgment. But with that authority comes immense responsibility. Every time you affix your seal to a document, you are making a legal and ethical promise. You are stating that you have personally reviewed the work, and that, in your professional judgment, it meets all applicable codes and standards and is safe for the public. If that design fails, if a roof collapses or a foundation cracks, the liability, both civil and potentially criminal, can trace directly back to you. Your seal is your bond. It's a statement that you are willing to stake your professional reputation, your financial well-being, and your personal freedom on the quality and safety of your work. This is why the path is so long and so difficult. It has to be. The public places a sacred trust in the engineering profession. People drive over bridges, work in tall buildings, and drink clean water with the implicit faith that the engineers who designed these systems were competent and ethical. The P license is the bedrock of that trust. It is a filter designed to ensure that only those with the proven technical knowledge, the required experience, and the ethical character are granted the authority to make decisions that impact public health, safety, and welfare. Looking back, from the vantage point of a licensed professional engineer, the entire journey makes sense. Every late-night study session for thermodynamics, every tedious calculation in your first job, every challenging project that pushed your limits, and every hour spent preparing for that final grueling exam, they were all necessary steps. They were forging you, testing you, and preparing you for the responsibility you now hold. Becoming a professional engineer is more than a career milestone. It's a transformation. It's a commitment to a lifetime of learning, as you'll be required to complete continuing education credits to maintain your license. It's an entry into a community of professionals bound by a common code of ethics. And most importantly, it is an acceptance of a solemn duty to serve humanity by making the world a safer, more efficient, and better place. The journey is long. It is arduous. It will test your limits in every conceivable way. But for those who undertake it and see it through to the end, the reward is not just a set of letters after your name or a stamp on your desk. It is the quiet confidence of knowing you have met one of the highest standards in the professional world. It is the respect of your peers and the trust of the public. It is the ability to look at the infrastructure that forms the backbone of our civilization and know that you have the skill, the authority, and the integrity to build it. It is a difficult path, and that is precisely what makes it so incredibly worthwhile.